Hi quick learners, welcome back to quick learning. So today we are going to talk about the time complexity. Okay, now building the algorithm for solving a particular problem, we usually talk about the two questions. Okay, the first one, how much time will our algorithm take to solve a particular problem, and how much memory will our algorithm consume for solving a particular problem. Correct? So we usually talk about the two question. Correct? So we have to build the effective algorithm that can solve the problem in acceptable amount of time with the acceptable amount of memory consumption. For this we are going to master the concept of time complexity here. So what exactly time complexity? So time complexity is the execution of algorithm considering only and only algorithm and its input. Okay, it's not about the time required to execute code, it's only about the algorithm and its input. Correct? So we are going to provide different inputs to the same algorithm. We'll increase the input size, we will see how well it performs, how much time it takes, how lesser time or how more time it takes to solve a given problem. Correct? Now to express the time complexity we use the big O notation. Correct? Now what exactly big O notation? Now big O notation is used to compare the efficiency of different algorithm. It is used to compare the efficiency of different algorithm. It's a mathematical notation, you can say. So there are different big O notation like constant time complexity, which is nothing but the O of 1, linear time complexity, which is nothing but the O of n, logarithmic time complexity, which is nothing but the O of log n. After that, quadratic time complexity, which is nothing but the O of n square. And lastly, exponential time complexity, which is nothing but the O of 2 power n. Correct? So these are nothing but the big O notation. Now when we express the time complexity using this big O notation, we usually talk about the worst case scenario. Correct? We usually talk about the worst case scenario of a particular algorithm given the large input size. But we can also express with the best case scenario and as well as average case scenario. Okay, so best case scenario is nothing but the O of 1. Worst case scenario is nothing but the O of n. Now if we are trying to find an element in an array using the linear search, okay, where we go through array element one at a time. Correct? The best case scenario is O of 1, where we find the element right at the first index in the array. Okay, this is nothing but the best case scenario. Now let's talk about the worst case scenario, is where we can find the element in the last index of an array. Correct? So this is nothing but the worst case scenario. Now if we talk about the average case scenario, where we find the element right in the middle. Correct? So this is nothing but the average case. So we express different time complexity, the worst case, best case and average case. But we often talk about the worst case scenario. Now let's understand more through examples. Okay, now this function runs in O of 1, which is nothing but the constant time complexity. Correct? Now the input array could be one atom, or maybe it can be 1000 atoms also, but this function will still just require only one step. Correct? So the time complexity is nothing but the O of 1, which is nothing but the constant time. So this is the example of constant time complexity. Now this function runs in O of n time complexity, which is nothing but the linear time complexity. Okay, where n is nothing but the number of atoms in the array. Correct? If the array has 10 items, correct, we have to print it at 10 times. So if an array has 10 items, so we have to print it at 10 times. If it is has 1000 atoms, so we have to print 1000 times. So its time complexity is nothing but the O of n, which is nothing but the linear time, which is depend upon the size of an array. Now let's talk about the quadratic time complexity. Now here we are nesting two loops, right? If our array has n items, our outer loop will run n times, our inner loop runs n times for each iteration of the outer loop. So giving us total n square prints. So if the array has 10 items, correct, if the array has 10 items, we have to print 100 times, correct. So this function runs in O of n square time, which is nothing but the quadratic time. This function runs in quadratic time. Now let's talk about the exponential function. So if you see, this is the recursive calculation of Fibonacci series, where O of 2 power n denotes of an algorithm whose growth double with each addition to the input data set. So this is nothing but the example of O of 2 power n, which is nothing but the exponential time complexity, correct. So time complexity is described in the different scenarios, where the best case, the worst case and average case. The best case scenario is nothing but the constant time complexity. The worst case scenario is nothing but the what, linear time complexity. So this is all about the time complexity. Subscribe for more.